Hi everybody, it's Miss Miseraco here, and today I am only going to give you a video for the lab portion of the activity that we did today in class, looking at conservation of mass. So you'll want to go and complete the rest on your own. There was a gizmo, and then this lab part that I'm going to do with you right now, and then we kind of did a little bit more of the gizmo for an extension. So please do the bookend parts with the gizmo, and right now is the lab conservation of matter or mass. So for today's activity, we have two different solid solutions or materials and a liquid. The first is baking soda. So I think on page 73 of your digital notebook, it asks for you to describe the baking soda. So you might say it's a solid, you might say it's a powder. Those are all words you could use to describe this substance. Again, it is white in color, might be something else you include. The other one is calcium chloride, and this one kind of looks like Dippin' Dots or little pellets here. They're spherical, they're a solid, they are white in color. Again, those are observations you could record for this calcium chloride. I believe it's the first one that's listed in your chart. And then our liquid for today is a phenol red. So it is obviously a liquid, it is red in color, looks kind of like cherry Kool-Aid. So for today's experiment, you are going to, or I am going to for you, take about a half a teaspoon, which is about 2.5 grams of each of the solid substances, and put it in this Ziploc bag. So here I'm going to put about a half a teaspoon of my baking soda in. I'm going to put about a half a teaspoon of my calcium chloride in. And then I'm going to measure using this scientific tool called a graduated cylinder, 5 milliliters of phenol red. And I'm going to put that in a little plastic cup to keep it separate from the solid. So I put that in there. I'm going to put that in my Ziploc bag. I'm going to squeeze out a little excess air, and I'm sealing the bag. By sealing the bag, I am making a closed system. So now would be a good time to think about what could your hypothesis be? If I'm doing an experiment in a closed system, what do you think the mass is going to be at both the beginning and the end? Will it change or will it be the same? Okay, so now I'm going to find the mass. I'm going to put it on this digital scale that I have here, and it looks to be about 17.4 grams. So write that down, please. The initial mass of the reactants is 17.4. So now I'm going to tip my cup into the solid part. I want to try and get this the best I can here. So I'm going to dip and tip that in there, and I see this happening. Right now, I've got a color change. I'm seeing a lot of bubbles happening, and if you were to touch this, it is warm. So that indicates an exothermic change is happening when these bonds are being broken and new bonds are being formed in this chemical reaction. Also, you might notice this bag is kind of puffing up. Remember initially I said I was going to take and squeeze some of the air out of that, so a gas is being produced by that bubbling, and it's puffing up my bag. So now I'm going to find the mass of the end here, and it is 17.4. So the mass at the beginning of the experiment and at the end of the experiment was the same. And that's because it occurred in this closed system. That's all I've got for you today. Again, you want to go and do the gizmo parts at the beginning. There was a nice visualization of conservation of mass, and then there was an extension at the end. Check back with your teacher if you have any questions or concerns. Thanks for watching.